So I see that you have like a cabinet that's modeled in here, right?
Yeah, and all the different parts are color coded.
Okay. Now, do you model these in Rhino, or was this modeled in and imported in?
I did it in Rhino. Yep.
Okay, great. Okay. All right. So the first step here would be in order to machine this, this is currently in assembly what you have, right? You lay them out together like how your finished product should look like for the cabinet part. So to be able to machine them, you need to basically flatten them out to be able to basically, and then you can fit it into a sheet to machine it. So to automate some of these processes, we have a tool called Explode Cabinet Design. So this is available to you in RhinoCAM standard and higher configurations. So you can say Explode Cabinet Design, and you can now select to explode all the visible geometries, or you can say export only selected, or export lay objects in certain layers. And then you can choose how you want it to be exploded and place them. You can say single row along X, so it'll basically place them along X. Or I can do it along Y, or you can array them in a fixed distance and specify the fixed distance on the X, or you can do fixed distance on the Y. So this is basically to flatten them out right now. And then you can specify the spacing between each part as you flatten them out. And you can also specify whether you want to output them as just curves only, 2D curves. You could do that, or you could say you want to do a 3D model and 2D curves. You can select that. You can choose to keep them in the parent layer. And also you can say hide the original geometry and then place all the curves on one plane. So if you choose both 3D geometry and 2D curves, RhinoCAM will go ahead and create curves around each and every feature, like holes. You can have slots, dados. It'll create curves. So once you have these selected, you click OK, and it automatically does flatten them out for you.
Okay.
So basically all we did was we flattened it out so it's on an XY plane. And if you basically select this, if I hide this here, you can see it's also creating curves for each of these. And I chose to put the curves on one plane rather than keeping the curves on top of the 3D model. Okay? So we could either extract them. Sorry, go ahead, sir.
Do what you just did again. Have the curves not on top of the.
Yeah, I just chose to put all the curves on one plane because a lot of our users, when they do some cabinet work, they're working with 2D geometries and they know how deep it needs to be. So they basically pick this and specify the depth of cut, how deep it needs to cut. So they just work
instead of having. Okay, so if you zoom out and look at the yellow panel, and then towards the other side of them, there's the rabbit cut there on the edge. No, you're other way.
Oh, over here. Okay, right here.
Right here. So that would just be a 2D geometry.
Yeah, we could do a profile. Yeah, you just have a line here to do a profile cut on one of the sides.
Okay, gotcha.
Yeah, we could work with 3D models. That's not a problem. So I just wanted to show you we have options either to output them as 2D, 3D, or we could do both. Okay. All right. So now that we have this laid out, flattened out, we could go to the next step here, where we can place this, nest these parts into a sheet. So you can go from RhinoCAM-Mill to RhinoCAM-NEST. Okay. So right now I'm going to go into the top view here. Now I could take these parts and stage them out. So I could create my sheet over at the origin, right? So I could draw my sheet in here. I could say my sheet is going to be 4x8 or whatever the sheet size you're going to typically start with, or 5x10 or 4x8. So if it's going to be 4x8, I would say 4896, right? That creates or defines my sheet. So I can do a true shape nesting, select the sheet. So I'm going to pick this rectangle as my sheet in here. Click on select curves, select this as my sheet. So there's one sheet I've created in here. Now I could define the thickness. Do these parts have different thicknesses in here?
No, they're all 3/4 thick.
Okay, so I'm going to click on select parts to nest. So I'll put in a thickness of 3/4. And then I can specify how many sheets I need. I can put in a quantity here. I can then say select the parts to nest. And in this case, we have both solid geometries and curves in here. So what I'm going to do here is just pick the solid geometries. So I'll basically hide the curves, or I can lock the curves in here, or I can hide them. Okay. So I'm going to use
I'm a little bit. I'm trying to follow along with you. I'm a little bit behind you.
Okay.
Sorry, I got my rectangle drawn out for my 4x8 sheet.
Okay.
What do I?
And then you go into the nesting, and then you select the rectangle as your sheet.
Select curves.
Select. First, you got to draw it, and then click select curves, and then just highlight the rectangle.
Okay.
So select curves. You highlight it.
Got it. Got it. Yep.
And then you select that.
Okay.
Okay. Now over here, down at the bottom, we have curves as well as we have solid models, right? When I try to select these, there's 39 curves, 18 poly surfaces, and 5 extrusions in there.
Yep.
See them? So, when you nest them, you want to nest either the curves or the poly surfaces. You don't want to duplicate them because it'll treat the curves as separate and the solids as separate. So you can hide the curves in Rhino if you'd like to. You can, or you can, basically I'm going to just lock this in here, and then I can say select curve. Just type the select curve command. There's 59 curves added to selection. I can just do a hide. It'll hide those curves.
Okay, got it.
Then I'll just unlock this rectangle which I had. So we have one sheet. We have a thickness of 3/4 of an inch, right? We've defined the sheet thickness. And then we have the starting corner and nesting direction and grain direction here. We can set the grain direction to either along X, Y, or leave it as none if we do not need to specify grain direction. The next step is go to select parts to nest. And then over here, there's a button that says select parts. And when I click on it, it'll let me pick the parts. I'm just going to drag a window to select all of these. And it's going to list 23 parts. Okay. Now, there's a checkbox in here that says used for engraving and sign making. So if you had multiple nested geometries inside here, then I would select this checkbox. In this particular example, it's not going to make a difference because everything is just either a part and a whole or just a part by itself. So you don't have to select this checkbox. But if you do have multiple inside features, let's say you're working with some 2D geometries, you had, a outer shape and then 2 inner shapes, one inside the other nested profiles, then you need to select the checkbox in there. Okay. And then you go to choose nesting parameters. In this dialog, you would specify the distance between each part. So when you nest them, you want to make sure that you know what tool you're going to be using, so there's enough distance between each part as you nest them. So if you're going to be profiling these on the exterior with a 1/2 inch cutter, I want to make sure I at least have a 1/2 inch room, so I could say just give at least 100 thousandths more than 1/2 inch, 0.6 inches. And then the distance from the part to sheet is from the edge of the sheet to the part. How far you want to stay in. I could say just leave maybe 100 thousandths or even less, 50 thousandths, so that you don't have a factory edge being left on the machine part.
Okay.
And then in this particular case here, I can say estimate number of sheets. So this will basically determine how many sheets are required to nest these parts. So it says sheet 1, we need 2 sheets. I'm going to update the sheet count. Okay.
Okay.
And then I'm going to do execute nest.
Mine says estimate number of sheets 0.
Maybe you haven't specified a sheet thickness in there.
Select sheet to nest parts in.
Mm-hmm.
Sheet.
Yeah, sheet count. So, and then basically here it says one of these parts are not being nested, part number 9. So once I have these in here, I can go ahead and go to commit nest and say create nested sheet for each layer. And you can see it outputs the nested result. In the demo, you wouldn't be able to export it or output it. But here you can see there's a total of 4 layers I got right there. So my first sheet layout right here. Then my second layout. So based on the thickness, the next one right here, and the final one, right? So it's basically nesting the parts into a sheet. So we can either output them all in the same 3DM file as different layers, as you see right here, or you have an option to export it, and it'll export each sheet to a separate 3DM file. Okay?
Okay.
So now that we have this
still
exported,
behind. I'm still trying to follow along, but
okay, maybe what I can do is I'll
you.
get the recording after the demo, so you can go back and watch the recording and, practice it. So that way, you can go, you can do exactly the same things what we did.
Okay.
All right.
Gotcha.
Okay. Yep. So now that we have these exported here, these are the stage parts. I can hide them all together. I can just go ahead and say hide all of these. Okay. So these are the parts that have 4 different sheets. So if you wanted to program all of these within the same file, I'm just going to go from RhinoCAM-NEST back to mill. And as I save this file, I'm going to do a save as. I'll just call it revision 1. Now, all of this information is saved with the 3DM file, so there's no additional options being created, even including what we did in the nesting process. All the parameters are saved with it. Now we are ready to machine this part. So I'm going to go ahead and hide the layer manager. We have the parts ready to be machined. So I'm going to go into the mill browser. In the program tab, the first step is to define the machining process. So for 2 and 3 axis, by default, it's set to 3 axis. The next step is to select the post processor. This would be the machine tool that you're going to be generating the output for. The posts are listed either by the name of the machine or by the controller, or a combination of the two. We have over 300 plus posts included. So this covers a wide range of machine tools that are available out there. Would you know what type of machine?
Yeah, hold on. The guy that we're going to be sending our files to, he wants them in a .prg file, and he uses Aspire as his software.
.prg is it's an output file extension for the G code. So do you know what type of machine tool he's using? Is that like a...
he uses a Laguna Smart Shop 2.
Okay, so what we would select here is a Laguna Smart Shop 2. This SS is Smart Shop right here. And there's different controllers in a Smart Shop. They have what's called the BNR controller, or, so you'd select, if it's using the BNR, you pick Smart Shop 2, and then you can set the extension to .prg. So it's not listed in here. You can say add new and add a new extension, .prg. So that's how you set the extension.
Okay.
Okay, so Laguna Smart Shop 2, automatic tool change with BNR controller, if that's the BNR controller. So we have several customers who use our product with different types of Laguna machine tools. So now that we have this set up in here, we're now ready to cut this part. So there's different ways how we can program it. One of the ways is basically selecting curves or edges to program the tool paths. So we can start with a 2-axis operation. Say we first wanted to program some tool paths. Now before I get there, I defined the machine and selected the post. You can see that the machining job is automatically updated to the information. The next thing I'm going to do is define the stock. We'll select stock and box stock. And when you hit copy model box, the system automatically computes the stock extents, 48, 96, and 3/4 of an inch height. Now you can display the stock right on your screen, and you go to the Simulate tab, it displays the stock material that you created. Now if you select the stock material to wood, you can also display a texture, and the texture will appear in the simulation as well. You can hide or show the texture in the simulation. Okay? So the next step is to basically cut the profiles. Before you cut the profiles, you want to take care of these holes in here, machining these holes, right? So we have what's called feature detection and machining in RhinoCAM standard. We can identify different feature types. I can use feature detection, and I can just go select all of these parts in here, and RhinoCAM will identify the features in the model. So it's detecting the features. So this is how we can select a feature to machine toolpaths to generate toolpaths. So it's called automatic feature detection. All I did was I selected each of those panels in here to detect the features. You can see it identified several silhouettes around the part. Silhouette feature identifies those. It identifies planar faces around the part, identifies holes around the part. The different feature types are being identified in here. So it identifies these as holes, as you can see right there. And if you select them, it also shows what the holes are, the diameter, the depth, all of this is identified from the feature. Okay? So there's 6 different types of holes that it identified on these parts, right? For each of these. As you can click on it, it shows the diameter of the hole as well as the depth. So once we have these features detected, we can go ahead and generate machining operations in here. The easiest way to do it is click this automatic feature machining. It's going to generate toolpaths for all of these features in one go. Or we can individually generate toolpaths as well. So I'm going to hit automatic feature machining. And in this process, it generated like a facing toolpath. So we don't need the facing toolpath really in here. So I'm going to remove them from the features. We'll do one facing operation if necessary for the entire sheet. But then there's a profiling toolpath that's generated to cut around the entire sheet, right? You can see it's cutting the profiles in here. And by default, it's using a 1/2 inch cutter. You can change it to a different tool. In the cutting parameters, cut levels, you can see the total depth is 3/4, but you can say you want to go in multiple steps of 1/4 inch each, or you can go in just one go if you want to just take it out in one pass. You can specify how you want to enter and leave the material so we can ramp along the path. And then you can also do a sorting to basically, minimize the transfer motions and make it more efficient. So there is the profile, as you can see here. It created a profile toolpath around each and every part. Okay? And then for the holes, it has a hole feature operation in here. It's doing a drilling operation for these holes. And you can basically select, based on the feature, these are 1/16 of an inch. So if you don't have a tool that's 1/16 of an inch, you can create a new tool, a drill bit, a 1/16 of an inch, and I can say drill 1/16. I can define the tool, specify the tool properties in here, the tool length, shoulder length, flute length. You can give it a number for the tool in here, save this up as a new tool. And then you can pick this drill tool we created and generate it. So this will basically take care of drilling these holes that are a 1/16 of an inch depth, right?
Cool.
And then for these holes that you have, these are larger holes. And you can see the hole feature, it says 0.3125. There's 2 holes, they group them together. So you can use a 3125 drill bit. So it says the closest drill we have in the library for that that's close enough to 0.3125 is a 1/4 inch, because my library did not have a tool that matched it. So I can go back and add a new tool in here, and I could say drill 0.3125 if you want to use a 0.3125 drill bit. But if you don't want to do a drill operation, you want to use use a 1/4 inch bit, but then do like a profile operation in here, we can show you how to do that as well. So you may not have tools that match the size of the drilled holes. So you can use a different operation to program it. So I'm going to add a new tool in here, generate it. So there's the drill operation. And then finally, we have these larger holes, and their diameter is 1.375. So typically, you want to drill them first and then you want to go back and do what is called a pocket machining, whole pocket machining. So I'm going to show you how to do that here. So now this operation is generated. Right-click regenerate will update all of this. Now I have this whole feature number 3 or whole feature number 4 right here, whole feature 4. Then we have whole feature number 6. So I can select this, right-click, and choose an operation to program. It's like a whole pocketing or a whole profiling, or I could even interactively select the features, right-click, and then program an operation. So for this whole feature, number 4, I'll right-click on this, and I can select the operation to program. So in this case, I'm going to do a whole pocket machining operation. I'll pick that. I can also go back and add an additional feature in here. Select the feature. I can also add these together, so I can program both of them in one go because they are the same size. Then I can specify the tool, use the 1/2 inch end mill. In the cutting parameters, I can specify to create helical cut patterns, specify helix pitch in here, and then I could generate the toolpath. So that's going to give us a whole pocket operation, like a whole profile to clear it out. So the first step is to do a drill and then go back and do a profile. Now let's go ahead and take a look at the simulations. I'm going to reorder the operation. So we have the whole features being drilled first, and then we're going to do the profiling. So we'll select the setup, right click, and then simulate. So that gives you a cut material simulation.
Oh, cool.
You can always speed up the simulation as well.
That's awesome.
Yep. So this, you can also hide the display of the toolpath. You can speed up the simulation in here. And there's the whole profiling after the drilling is performed. So once the whole profiling is done, you can always pause it and then do simulate to end. You can do a pause, simulate to end. So that basically goes to simulate to end. It runs through the simulation for each and every process. And then we have the profiling here, which basically cuts out the entire sheet, right? It relieves the material. So if these are vacuum held, then you can just cut them out. Or if you need to do bridges and tabs, we do have an option to do that in profiling. We can do bridges and tabs. You could always go in here and speed up the simulation to have it go faster. You could always do pause, go to end, simulate to end. Now you had a question about cutting these, I would call these as slots right here, like an open slot that you have, right?
Yeah, they're called rabbits.
Rabbits, okay. So we have what is called a planar face in here. I can do a profiling for the planar face. I can remove all, select features. So I can select that feature in here and do a profiling. I should be able to select that face. Yeah, planar face right there. And then I can grab the tool for it and specify my cutting conditions and generate. So that should give us a profile toolpath. So you can see it's going around the entire planar face. So that's not what we want to generate here using a feature-based. So what we would do is the easiest way for us to do is use a non-feature-based machining technique. And I can measure or analyze this distance in here. So I can see how wide this is. That's about a 1/2 inch wide. So we can just use a 1/2 inch cutter to just run one pass. And we can do profiling 2 axis. And all I do is just pick this edge and pick the edge right here. Then specify a tool. In the cutting, I could choose to automatically determine based on the 3D model. We chose the feature at the bottom of the pocket, and then I can give it a depth by just picking 2 points. And you want to do it in 2 passes, 2 steps. You could do 2 steps. You could specify entry and exit, how far out you want the cutter to enter or start from outside the material. So you can specify all of these parameters in here. Generate it. So that'll basically give us a path to clean that step out. And this could be the operation before you cut the profile. So you can do this. And then I can go in here, do a simulate to end. So you can do a combination of feature-based and by the conventional way of selecting features for machining. So if I wanted to cut this to a different depth, you don't have to go back and change your design. You could just do like a hole pocketing or profiling, and you can specify how deep you want it to cut. Or if you want the hole to be slightly oversized, you can override the diameter in here. If you analyze the diameter of this hole, it turns out to be 1 3/8, right? So instead of, if you want to make it like 1.4, I could say 1.4 in here. I can change it, and then the whole depth I can pick it from the 3D model.
Gotcha.
And then I can override the depth. I can say the depth has to be only 0.5, and you can always make these adjustments and then generate the toolpath. So there's a couple of ways how we can generate it by using features. We talked about feature detection and machining, or you could even select edges or arcs, curves, 2D geometries, and generate toolpaths. Now, once you have these operations programmed and generated, you could save your file in Rhino. It saves all of the machining data that you create with the same 3DM file. If you're now ready to post-process, right-click and do a post. And you can choose the folder where you want to save the output file to. And there's your posted code, which shows up in a text editor like a notepad.
Whoa, cool.
And this is the file you'd want to send it to whoever's going to be running the machine. This is the code output for a Laguna Smart Shop. Its extension is set to PRG.
And so theoretically, he should be able to just plug this code into his machine and then it works, right?
Right. Ideally, yes, that would be the case. You want to make sure that you're having the tools that's matching his tool changer. Typically, on a Laguna machine, there's probably up to 8 or 9 tools. I'm not sure if it has an automatic tool changer. So you want to make sure the tool numbers are set correctly. In the demo, I said a 16th-inch triangle drill showed up a tool number of 16 I picked. And then also where you're setting the 000, on most Laguna machines, they recommend setting the 0 to the bottom of the stock material, which is the top of their table or the top of the spoil board. So you want to make sure that lines up correctly. And then once you program it, you're ready to send this code out to the machine.
Cool.
So one of the benefits of RhinoCAM is being able to reuse these operations on other files. We have a feature called knowledge base. So I'm going to go ahead and save these to a knowledge base. So this will allow me to save. So I'm going to basically save this over here, save it to a knowledge base. Now, when I want to program, let's say, another part, in this case, I'm going to take the sheet number 2 that we have in here, right? I'll right-click and say export. I'll say select objects. I'll say select all on the sheet. I'll hide this sheet right in here. Or let's go pick a different one. Okay, this sheet has more objects in here. So right-click, select objects or select all. And then I can do an export selected in Rhino. And I can go ahead and say sheet 2. Okay. Save this up. So now if I go back and open the sheet 2, considering that this is probably from a different design that you have, right? You have a bunch of parts in here. Now to machine this, the workflow would be very similar. You define your machine, you select the post. You can see they're already set up. I'm going to create my stock in here. And then, set my 0, 0 to the lower left corner, which is already there. Now I can detect all the features on this model. So basically, I'm just highlighting these parts right here. So it's detecting features, performing feature detection. And now the features have been detected. Rather than programming each and every toolpath, I can say load the knowledge base. And I'm going to load the knowledge base that we created on the other part. So the whole features. And you can see right now there's 3 different operations, and automatically also selected the features for us, right? You see that right there?
Yeah.
If I double click on it, it shows it's 0.0625, there's whole feature selected I generated. So we can automate the programming workflow. We can also set up rules for sorting to minimize the transfer motions just to make it more uniform. And I could now, do the same for each of these operations in here, right? You can double click on it and apply a sorting technique, and you can choose what tool you want to use, what features you want to cut. So these have 0.3125, 1. If you're going to be using the 1/16th drill for this one, you can basically select those operations with it and then program it. And then the same thing goes with the profiling the outside in here. You'll notice that it automatically picked all of the features. I had to right click and regenerate. And if I want to make any changes, I just go back in here to cut levels, and I can specify the depth per cut. If I want to do it in 2 steps, change it right there. That'll give us multiple steps.
Cool.
So the knowledge base is a very powerful way of reusing your entire workflow. And if you want to delete any operations from the knowledge base, you just highlight it, hit delete. That'll delete it for you. Right click, regenerate. It says one of the operations does not have any machining features selected in here, this profile. So in this case, I'm just going to double click on this. I'm going to go back and select the edge right in here, the edge right there. I'm going to pick the edge at the bottom of this part, and this one right here. Right click, generate it. So that generates the toolpath. So automation. You can also, if you're just working with 2D geometries, we can select rules for selection. So you can load the knowledge base into this tab called K-bases. And for example, I can go into this profiling operation in here. I can say selection rules and say I want to select objects based on a certain color. These apply for curves. Or I can say apply based on a layer. So it'll automatically pick all the objects either of a certain color or a layer when you apply the rules. Or you can even apply based on features. So apply a profiling toolpath to all, prismatic, like a boss feature or a pocket feature. If you want to do a silhouette feature, you can apply it as well. And then save them to a knowledge base.
Awesome.
Any questions so far?
Yeah, so when laying the sheets out to begin with, is there a way to orient them according to grain of wood or material?
Yes,
like
yes, there is. You can do according to grain direction. So let me go back into the file we started with. Right, this was one of the files, but let me go into the other one where we already had it flattened out. So let's go into the layer manager. Okay. Let's go into the nesting module. Now, if you go in here, you see it says sheet number 1.
Yep.
Name of the sheet. You can specify the grain direction. So you can set the grain direction to be along X or along Y. You can set it up for the sheet. So for example, I pick along X for the sheet. And now I go to the parts that I'm nesting. And when I highlight it, it shows each and every part. And you can specify the grain direction for each of the parts. Now, by default, if it's set to none, it'll automatically orient it to the grain direction of the sheet. So in this particular case, for this part, I can say I want the grain direction to be along Y. Okay? So this part, I'm changing the grain direction to be along Y. I could do the same for these parts as well. Or if I want to change it for all of the parts, then I would rather set it on the sheet itself. Okay? So once I do that, I go in here to execute the nest. So when I do an execute nest, say some parts could not be nested. Maybe there were some parts that were smaller. And you'll now notice that these parts are being oriented along the grain direction, as you see it right here.
Yeah, I see. Okay.
Okay. So you can apply grain direction, set for the sheet, and then you can override the grain direction for the parts.
Cool.
Any other questions I can help you?
Let's see. Would you say with this type of project, like these parts, where it's just like flat sheet, would you say that doing it as 3D objects is better or worse than doing it as 2D curves?
Well, if you do it as 2D curves, they both have their own advantages, one over the other. So if you're doing it with 2D curves, then you need to be able to specify the depth and stuff like that, right? You need to know, like, how deep are these blind pockets, how deep you need to drill these, and then you probably would need to know how these are these rabbit cuts that you talked about. You need to have information on them. So you can do it.
But if I'm so it'll modeling those when I'm in the modeling process could actually, it's basically I either model it in 3D or I tell it numerical depth, basically.
Well, here's the nice thing. Even if you model it in 3D, we can, when we do the explode cabinet design, we can do it in 2D. So let me show that to you here. So let me go back. I'll go back in here. I'll remove all of these parts. Okay, I'll select these. I'm going to show all the curves, right? I'm going to select all the poly surfaces, hide them. So basically what we have is curves, a bunch of curves. Okay, so we have these bunch of curves in here, right? So that we created using explode cabinet design. Okay. Yeah. So you can also see that RhinoCam automatically applies different colors for each of these based on a hole or a feature or whatever they are. It creates different colors in here. And you can see there's a line in here. It shows where you have that step right there, right? On this part right here, it shows the line. Now, we can nest these as 2D. So I just put the thickness as 0 when I nest it. Select the parts to nest. Then I go through the same process in here. Estimate number of sheets. There's 3 sheets. Update the sheet count. Execute the nest. It's going to create a nested result here. Give me one moment. Did Rhino? I think Rhino exited on here. Let me bring it up.
Oh, wow.
Yeah, so we can basically nest those curves as well into the sheet, and then that should also work. So, and then we can apply rules for selection, like we talked about how we can do the selection rules. So we can apply rules to automatically select, pick all of the geometries of magenta color to do the profile for the outside, or pick all the holes to do a drill or to do a pocket, so you can automate it. So it just basically comes down to, depending on the project, whether you want to do work with solid models or 2D. You can do both.
Cool. Okay.
A combination of either one.
Wow. I mean, this is like exactly what we're trying to do. So I'm pretty impressed.
Yep. And one of the strengths of RhinoCam is the ease of use. It completely integrates into Rhino, so you don't have to leave the Rhino interface to do these, what you've been doing in Rhino. Stay within Rhino to be able to go from your design to be able to nest them and to machine them.
Now, for example, so you got everything laid out right there. Could I select one of those pieces, one of those parts, and alter the geometry like it was just a 3D model, and then
once you have it nested here, you can make changes to it. Once it's nested, it's just still a Rhino part. You can make any changes to it.
Cool, and so if like I decided
before you machine it, and then you can go back and detect features and machine. If you detect the features and then make a change, it'll drop those features. You got to go back and detect the features again.
So if I decided I wanted, because these pockets, these big holes right here are for hinges. So for example, say all of a sudden I decided I wanted to change the type of hinge and I needed to make different holes, I could just do that right here in this.
Yeah, you're still
layout,
completely inside of Rhino, and you can make those changes to it.
Cool.
Okay. The only thing is the features will be deleted when you make a design change to the solid part. You got to detect them again. Now, if you're working as curves, then you just reselect the curves for machining. If you added a feature, if you made a change, you just reselect them.
Awesome. All right.
Okay.
Yeah. Well, that was a great little tutorial. Thank you.
Thank you. So if you could give me one moment, let me go ahead and pause the recording here.
Okay.